This is a teacher's guide to the division intervention. We're at step 5. In step 5, now we introduce double-digit divisors. All divisors in steps 5, 6, and 7 are 10, 11, and 12. So even though we're introducing double digits, we lower the cognitive demand because we're using only divisors that are in the place or that are in the multiplication table if you have 1 through 12. And of course you need 1 through 12 because we want students who don't have automaticity of fact retrieval to have that scaffold or that support. Even kids that do, they're probably not going to have their double-digit fact retrieval. So now for those that do have automatic retrieval of multiplication facts, the division chart or the multiplication table may become valuable and useful to them now. Eventually, in step 8, we finally take them to the place where they have to just estimate and test. But while we're developing the procedure, we want to keep that step simple and easy. So that's why 10, 11, and 12 for the next 3 steps. So double digit into double digit. Step 6 will be double digit into triple digit, and you're beginning to get the stepping process. Step 5 first part, no remainders. Step 5 second part, we'll add a remainder. So let's just go ahead and do that in this demo video. So we're taking 46 divided by 11. All problems are presented in this format. Students are now expected to be able to put it into the standard operational form for a completed division problem. Again, you might want to still be repeating the questions. What I'm breaking up or what I'm putting into groups goes inside. The number of groups I'm forming goes outside. The answer will be how many items end up in each group, each of the 11 groups when I divide these up equally, and then how many do I have left over. So other than that, everything is exactly the same. No scaffolds in the answers anymore. Kids are just expected to be able to tell us the answer now with reasoning. No stacking method. We're just going to go through a straight method. We're still going to ask the same questions, and you'll see that nothing's changed. Even though they're double-digit divisors now, I can still go through the same set of questions. Just don't even really point out that it's not even necessary for them to think about the fact that this is a double digit. We know that we need to find out how many times 11 will go as we're grouping because of the process that we've hopefully started to fix into long-term memory schema. We ask ourselves, how many times does 11 go into 4? And it won't, because I can't take 4 and break it up equally into 11 different groups. I can only get it into 4 of them. So I have to go to the next digit. How many times will 11 go into 46? So then I go to my chart and search my facts. And hopefully, like with 11s, kids could do this without searching their facts. They're going to get to 4, hopefully quickly, because we know that 11 times 4 is 44. And we can't go over 46 because we can't divide, we can't distribute things into groups that we don't have. So if we used 11 times 5, we'd be over. We'd be trying to distribute, or we'd be trying to group things that we don't have. So we can't go over. 11 times 4 is 44. That's in the units, so that works. Do the subtraction, and we have a remainder of 2. So this one ends up being pretty simple. The answer is 4, remainder of 2. So kids should be able to tell you. When I take 46 items, divide them into 11 equal groups, the closest I can get is each group will have 4, and then I have 2 more remaining. So incorporate a simple scenario. And this is maybe I have 4. Oh, so this is a cookie problem. I have 46 cookies I'm bringing to share with the class, which is me and 10 other people. So there are 11 of us in the class. How many cookies can I give to each person? And the answer is each person will get 4 cookies, and then I'll have 2 to take home to my brother or eat on the way home from school. Just have some fun with that. No need to go any further. That's all there is to it. So you can see all the repetitions still in there. Oh, yeah, remainder of 2. So same questions over and over and over again. Hopefully kids will quickly stop having to ask the question, will 11 go into 4? Because it never will. And when they see a double digit, then their mind will start to understand that, oh, I just go straight to the second digit. But you don't have to start them there because that may be confusing. What's the difference? Have them come to that conclusion on their own. That's where the inquiry aspect comes into play. And that's pretty much